Notes 8.2 are on graphing circles. For each of the following equations of a circle, we're going to do 5 things. We'll start by identifying the center and radius. So in number 1, the center of the circle can be found by looking at this center radius form. I'm going to set up C for center, and the ordered pair is -3, -4. The radius is the square root of the number on this side of the equal sign. So the square root of 16 is 4. Part B, state the quadrant or the axis in which the center of the circle is located. So let's review that. Here are the 4 quadrants. They start up here as quadrant 1, and then we go 2, 3, and 4. Our center happens to be down in the 3rd quadrant. We usually write the Roman numeral 3 to represent the 3rd quadrant. Part C is to sketch the graph of the circle. So let us go to the graph and plot a point at -3, -4. Next, I'm going to use the radius to help me out. Since the radius is 4, I could plot a point on the circle 4 units away from the center. So from the center, I'll put a C for center, I'm going to go up 4 units and drop a point. That will be on the circle. Then I'll go to the left 4 units and drop a point, go down 4 units, and then go to the right 4 units. Then you need to connect the dots. Try to round it out a little bit. If you've ever had to run bases for baseball or softball, you just kind of head toward it, not straight toward it, but you head toward it to the right of it to come around, and that'll make it look more rounded. Part D, we need to find the area of the circle. Do you remember area formula is pi r squared? So all we have to do is substitute in 4 for r, and we get 16 pi. Part E is circumference of the circle. Circumference is 2 pi r. Substitute 4 in for r, and we get 8 pi. So that concludes number 1. Number 2, the center of this circle is at 2, 0. The radius is the square root of 36, so that is 6. Part B, the center of the circle is located right here at 2, 0, which is on the positive x-axis. Let's sketch the circle. The radius is 6, so I'm going to go up 6 units from the center and plot a point. I'll go left and down and to the right. Remember to try to round it out when you sketch it in. So you don't head straight for the other point, you kind of head to the right of it a little bit. Part D is area of the circle. So area is going to be pi times 6 squared. That's 36 pi. Circumference of the circle is 2 times pi times 6, which is 12 pi. There are 4 more questions like this one. Please pause the video and do problems 3 through 6. Then turn the video back on to check your answers. The square root of 15 is really close to the square root of 16. Square root of 16 is 4. So that means the square root of 15 is just under 4. So I'm going to go up 4 units and then come back just a little bit. Then I'm going to go to the left 4 units but come back just a little bit. So it's just under 4. The radius is the square root of 10. That is just above the square root of 9. And we know the square root of 9 is 3. So I'm going to go up 3 and then a little bit past that. So go a little bit past 3 units away from the center. The center of our circle is located at 0, -3. That's on the y-axis, and it's on the negative side of the y-axis. Now let's work backwards a little bit. I'm going to give you the graph of a circle, and you can give me some of the information. For the first example, we have this circle. It has center at 4, 5. The radius of the circle, I can count out to the right or left or up or down, and I'll get 2 for the radius. So now we can write the equation of the circle. Do you remember the formula? The formula is x minus h squared plus y minus k squared equals radius squared. So we get x minus 4 squared plus y minus 5 squared, and don't forget to square the radius, which would be 4. The next circle. The next circle has its center at 2, -1. And if I count out to the left or the right, the radius is 3. So the equation of the circle is x minus 2 squared plus y plus 1 squared equals 3 squared, which is 9. Do the next example on your own. So pause the video to do that example and then turn the video back on to check your answer. We're going to analyze what is happening a little closer. We have the equation of a circle given to us, and we're going to answer a few questions. If we wanted to, we could graph this circle on the graph provided. I will do that to start with. The center of the circle is at 4, -3. The radius of the circle is 4. Here's a picture of that circle. Identify 2 points that are on the circle. The simplest thing to do is choose 2 of the points that we already graphed that helped us draw the circle in the first place. We drew point 4, 1, and we drew point 0, -3. So those are 2 points that are on the circle. You could have also stated 4, -7 or 8, -3. Any of those 2 points would do. Of course, there's an infinite number of points on the circle, but those ones are easy to identify. Now in number 2, we want to look at 2 points that are inside the circle. And there are several to choose from. If I decide to pick this point at 5, -1, that is inside the circle. And then if I choose 2, -4, that is inside the circle. So that answers the question. But what if we didn't have the picture to look at? So what we could do is use the equation to help us. The equation of the circle is x minus 4 squared plus y plus 3 squared equals 16. We know that from up above. Did you know that your ordered pairs are samples of x, y coordinates? So the first one I chose, 5, -1, is a sample of x being 5 and y is -1. And what I can do is I can substitute those into the equation of the circle. Put 5 in for x, we would get 5 minus 4 squared, and then put -1 in for y, we would get -1 plus 3 squared. What's happening here? Well, 5 minus 4 is 1, squared is 1. -1 plus 3 is positive 2, squared is 4. Look at 1 plus 4. Isn't that less than 16? So points that you find inside the circle would result in a sum over here less than the number on the right side. So in this case it was a 16. Now if we pick 2 points outside the circle for number 3, let's go up above. So let's pick the point 2, 2. That is a point outside the circle, and we could just pick 2, 3. You could also pick the origin. Well, how do you know that's outside the circle? If you substitute those numbers into the equation of the circle, what do you think will happen? Here's the equation of the circle. X minus 4 quantity squared plus y plus 3 quantity squared is 16. I'm going to substitute in a 2 for x and a 2 for y from our ordered pair 2, 2. That would give me 2 minus 4 squared and 2 plus 3 squared. 2 minus 4 is -2, and when you square that, you get 4. 2 plus 3 is 5. 5 squared is 25. Can you tell that 4 plus 25 is greater than 16? So we're finding out that if the point you pick makes the equation less than 16, it's inside the circle. If the points you pick make the equation greater than 16, it would be outside the circle. Okay, let's practice this again. In number 4, without using the graph, is the point 2, 4 inside, outside, or on the circle of the equation given here? So all you have to do is take the number 2 and the number 4 from the ordered pair and substitute them in for x and y. If you get x minus h squared plus y minus k squared is less than the radius squared, it is inside the circle. If you get x minus h squared plus y minus k squared is equal to r squared, then it is on the circle. It's part of the circle. And then, of course, the last option would be is if you get a greater than r squared, then it would be outside the circle. Here we go. Substitute in 2 for x and 4 for y, and see how that compares to 17. 2 plus 5 is 7, squared is 49. 4 minus 2 is 2, squared is 4. So I'm actually getting 49 plus 4 is greater than 17. That means the point is outside the circle. Now it's your turn. Pause the video and work out number 5 and 6. Then turn the video back on to check your answer.